In this video, we are going to focus on Boolean expressions and conditional logic. For your program to be able to make decisions by either using an if statement or some of the loop constructs, we have to be able to evaluate state information in such a way that we yield a true or a false value. The simplest Bool expression or Boolean expression, otherwise known as a logical expression, is to assign a literal constant of either true or false to a Boolean variable. In this case, we created a variable called value and assigned to it the simple expression of false. We can't use a 0 or a 1 here. In C#, the true or false constants must be used when assigning to a Bool variable. But we're not limited to a simple assignment expression such as this. We can also say value is equal to true and true, or true or true. The double ampersand represents a short-circuiting AND operator. Short-circuiting means if when it's evaluating both of these expressions together, it does not require the second one to determine if it should return true or false, it'll skip it. In this particular case, AND requires both sides of the operator to be true for the result to be true. So in this case, the only way you're going to ever short circuit an AND operation is if the first operand is false, because there's absolutely nothing you can do to the second operand to make this expression evaluate to true. Again, because the AND operator requires both operands, both sides of the AND sign, to be true for the result to be true. Now, OR is a little different. For the result to be true, either side or either operand must be true. In this case, they're both true, so the answer is definitely true. But if the first one is true, there is no reason to look at the second one, because there is nothing you can set this to that will change the overall result from true. Why? Because OR only requires one side or one operand to be true. So if we were to change this to false, you're still going to get an overall result of true. Another operator you may run into, besides AND and OR, is something called exclusive OR. Exclusive OR is similar to this OR, which, by the way, is called inclusive OR. It's similar because it's going to check if either one of these is true to return the value true, except with exclusive OR, only one of the operands can be true for the result to evaluate to true. So if I were to put true for both operands, this actually returns false now, because you can think about it as the operator saying one or the other, but not both. Where inclusive OR, either one can be true or both can be true for the result to be true. Also notice the short-circuiting operators use two symbols together to indicate they're short-circuiting, but the exclusive OR is a single operator or single symbol for the operator. That's because there's no way to write this in a short-circuiting manner, because it has to make sure that one side is true and the other side is false for the result to be true. So it has to evaluate both sides, which is why you will not see an operator such as this with two carets. And that brings up another point. There are non-short-circuiting versions of the same AND and OR operators. Again, they're going to use single symbols just like exclusive OR. However, because you lose the short-circuiting capability, you might actually decrease your program's performance, because now it has to evaluate both sides of the operator regardless of whether or not it needs to. For instance, on this one, we already know the left-hand operand is true. There is really no reason to evaluate the second one, but when we have non-short-circuiting operators, it has to evaluate both sides. If it's just two constants like this, you're not going to see that big of a difference. But if these are more complex operations or more complex expressions, then you could start to see performance degradation. So I'll put back the short-circuiting operators. I have not found too many reasons why you need to use the non-short-circuiting versions. Those are also overloads for bitwise testing, where you want to test individual bits to see if they're both on or off, and they are related to this Boolean logic. So bitwise logic and Boolean logic are very much related, except we're going to stay out of the bitwise discussion for this particular demonstration. Another Boolean operator that may be useful to you is called not. Not basically takes a single operand and flips the Boolean value, or toggles it from true to false or false back to true. So if we were to say value is equal to not true, that is essentially saying false. If we said not false, that would be true. Now, you're never going to see your code written like this, because we are just hard coding some Boolean constants in here, and that is not practical. So let's take a look at some practical examples using this Boolean type logic so we can add a little more complexity to our software. Let's start by adding a console write statement to ask the user to enter something. So we could say let's say enter Q to quit. This could possibly be a prompt at the end of every iteration of a loop to see if you want to quit the program. Then we need to read it in. All console input goes into a string value. We'll say console.readline. Then we are going to utilize this bool variable, or better yet, let's create a new one. We'll say bool quit is equal to, then we want to test this input to see if it equals the Q, which would indicate it's time to quit. So we could say bool quit is equal to, and I like to put this type of logic in parentheses just because for me it's easier to read, and I'll show you why. We'll say input equals Q as such. This is why I like to put it in parentheses, because we have this comparison operator used in the same statement as an assignment operator. That could get confusing if we were to remove this. As you can see, it's not quite as clear anymore. If we wrap it in parentheses, we know that this operation runs atomically or as one unit. From here, we could use an if statement to test what quit is. Say something like if quit, then do whatever action you need to do to quit. We could, of course, skip the entire temporary variable and just put this test directly into the if statement. We'll talk more about if statements in a different video. Right now, I just want to focus on the Boolean logic itself. Let's take a look at some more complex examples by using compound Boolean expressions. Let's create two variables, x and y, and we'll set them to some values, such as 10 and 1. We could then test to see if they're all positive. We'd say all pos is equal to, and now we can use a compound expression to test both x and y for being positive. First, what's the test for x being positive? We'd say x is greater than or equal to 0. We'll assume 0 is a positive value. If you wish to exclude 0, it would just be greater than. So it's equal to x is greater than or equal to 0, and y is greater than or equal to 0. If you feel more comfortable, you could, of course, wrap the entire compound expression inside parentheses. It really all depends on what you're more comfortable reading, and depending on how your fellow programmers, especially if you're in a team, if you have a set of standards you must follow. I prefer more parentheses and explicitness in my code just because I think it is easier to read in the long run, and it also indicates that this is what I intended. If you were to leave off all of the parentheses, and you're not familiar with the order of operations of C#, you may wonder if this evaluates prior to this. In reality, this expression works pretty much the same way as if we had the parentheses. If I run this program and get to this position, we'll notice x is 10 and y is 1. Notice when I hovered over the double ampersand, the and sign, it evaluated the whole expression for me. But it is, in fact, true. However, I do think that this is harder to read. If nothing else, maybe it's a good idea to at least wrap the entire outer expression in parentheses as such. It just makes it a little easier to read. Again, this is all going to come down to personal preference. If I have mismatched parentheses, as you can see, it will give you the little red squiggly line indicating you have an issue. What about one that requires, instead of an and, let's do a test that requires or. In this case, we want to test if either of the values x or y are positive. I can copy the entire line and say any positive, and instead of requiring both of them to be positive, we replace that with or. Now, if x is greater than 0, or greater than or equal to 0, or y is greater than or equal to 0, the expression evaluates to true. So if I were to change the code or the value of y to -1, we will still get a true value for any pos, but all will now evaluate to false because y is no longer greater than or equal to 0. We could do a very similar expression, and we'll call this either positive, and then use exclusive or to test the values. So we're saying if this is true, or exclusively this is true, but not both. In this case, this would also be true because it lines up with our test, because we have one of them is positive and the other is not. So this will evaluate to true, this evaluates to false. The entire expression will then evaluate to true because one or the other, but not both. If we're to make this positive again, now any pos is still true, all pos would still be true, or be true once again, but either pos would now be false because they are both true, and exclusive or requires one true and one false. What if you don't like to use parentheses in your code and you want to rely on the natural order of operations of the Boolean operators? In that case, I'm going to put a comment here and itemize how these operators would be evaluated when they are encountered in your code going from left to right without the parentheses. The highest precedence is not, followed by the non-short-circuiting and exclusive or and or operators. Then, finally, the short-circuiting and or operators. So not is always going to be evaluated first. So if we had an expression such as this, bool result is equal to not true, exclusive, or false. Well, let's take a peek at what the result of this is going to be. If we said that the not operator goes first, that will make this expression false, and then we test that exclusive or against false. False, exclusive or false is going to yield false, so the entire expression evaluates to false. But what if it did this first? Then it would evaluate this to true and then flip the bit to false as well. So that gives us, and for exclusive or, not much difference. But if we change this, we'll start with not true and not false. Well, let's make that an or. Ands are kind of uninteresting because if you have any falses showing up in the compound expression, the answer is false regardless. Or gives us a chance to be either true or false. So we have not true or not false and true. How does this expression evaluate? Well, as we know, the not operator is going to go first. So that would make this value false and then make this value true prior to looking at or and. Then, so what this ends up looking like, I'm just going to put a comment here, and we'll evaluate it one step at a time. Now we're left with or and operators. Notice that and is evaluated before or. They are not associative, so they are not going to be equally important. And will go first. So that means it'll evaluate this true and true, yield a true. So that means we'll have false or true. And then the final answer would be true, because true ORed with anything is true. Now, would there be a different result in this case if it tested the or first? Well, in that case, this would be true, and then this would be true, and the full result is now true. That is not always going to work out as cleanly as was just demonstrated, but it shows you the process that C# and the CLR go through when it evaluates your expressions. Again, if you're not comfortable with having all of these expressions laid out linearly without parentheses, by all means, add the parentheses. Likewise, if we had this expression, not true or false like this, this not will come after the or this time because everything is evaluated first within parentheses. So it evaluates true or false, which is true, and then negates it to false because the result of everything in the parentheses was true, not flips that to false. Clearly, this is just the start of working with Boolean logic. We are going to investigate this in further detail when we look at the if statement as well as some of the conditional loops where we will use more complex expressions to determine what branch of our code to execute next.